Hello everyone. I welcome you all to the seventh session of Data Analytics with R. I am Khitishwari Mishra, your instructor for today. Today we will discuss the programming fundamentals of R. Any programming language apart from R, if you know, like C, C++, Java, VB, .NET programming and any other programming, they have this common programming language techniques. What are they? They are constants, variables, data types, operators, data structures, control structures, functions. You will find all these seven type of structures in any programming language. So in R, you will also find it too. But in today's class, I will not cover all the topics, but rather to make you understand properly, I will pick up three main topics. The first three topics, that is constant, variable and data types. You need to know very well what are constants, what are variables and what are data types properly. First, let us consider the constants. What do you mean by constant? Constants are fixed quantity. They do not change its value. 2 is a constant. 3 is a constant. Your name, let's say Samarth, Ankit, Priyanka, Rita, Gita, Seema, etc. They are all constants. They are not same with any other constant. So they are a fixed quantity and termed as constant. They can be a number, they can be a name, they can be an ID, PAN number, a Boolean value, anything. But they do not change its value. That's why they are not known as constants. The examples I have listed, like 12 is a constant, it is a number, numeric constant. Then Hitishwari, that is my name, it is also constant. Suppose this is a PAN number and that is also a constant. It is an alphanumeric value where alphabets, digits, everything is there. Then suppose a flight number like 3 minus 6, 3 dash 6, that is also a constant. True is a Boolean value, that is also a constant. So whenever you deal with a lot of data during data analytics, you will deal with a lot of constants. Each piece of data is known as your constant and you have to deal with it. Now let us know more about constants and the type of constants you are going to deal with. First one I will talk, that is numeric constant. Okay. So what are numeric constants? Numeric constants are those constants which can be containing a number, and that is been categorized as integers or double or complex numbers. Integers means in R you can tell it as 1, 2, 3. They are all integers in a general world, but in R every number has to be associated with an L, capital L, to mark it as an integer. So in R, 1L will be called as integer, 2L will be called as integer, 3L known as integer, 35L known as integer. So they are integers if they are suffixed as preceded by an L symbol. What are doubles? Double constants are all the numbers, general numbers, 1, 2, 3.5, 90, 93.7, etc. etc. They are all double numbers. Complex numbers are in the form of x plus iy. That means if you write 2i means 0 plus 2i, or you can tell it as 1 plus 3i. 1 plus 3i, like this. So these are all numeric constants. The next type of constant is character constant. Character constants are written in the form of either single quote, suppose I will write a character within single quote, or we can write within double quotes. Within double quotes. Okay. Next is logical constants. Logical constants is the constants, the two constants that is termed as logical constant. They are true and false. They are logical constants. The last one is built-in constants. That means in R you will find a lot of built-in constants. What are the built-in constants? Let me tell you that letters is a built-in character constant. That means if we print letters, they will print all the alphabets in capital letters like this. Okay. And similarly, another built-in constant is letters in small letters. That means they will print A, B, C and so on. Okay. If we'll print month dot ABB, that means abbreviated months will be printed. Like they are Jan, Feb, MAR, March for March. Similarly, month dot name, they will have the full name like January, February and so on. Similarly, other built-in constants are also there like NA, null, NA underscore real underscore, that is one constant, built-in constant. NA underscore integer underscore, that is also another built-in constant. So there are predefined constants or built-in constants available in R also. So these are the types of constants you are going to deal with. Next, where you will keep these constants, because constants after printing they will go. They will simply run away. You cannot reuse it. So to reuse the constants, you need to store it somewhere. If you need to have the constants for further use, then you need to store somewhere. And how to store? You need to reserve a memory location under such a name. So that named memory location from your primary memory, temporarily reserved to store a constant value, is known as a variable. Okay. A named memory location to store the constant is known as a variable. And in R, how to deal with this variable, how to create a variable and how to store the values in it. Okay. So there are three types of syntax to create a variable. First one, var name, variable name equal to, you can store a constant to it. Similarly, var name, then left arrow and give a value to it. Or write down the value first, then right arrow and then the variable name. How we write the right arrow? Dash, then greater than symbol. How we write the left arrow? Less than symbol and dash. So that means if I need to create a variable and store it in, store a number called 5 to it, then how to declare it, how to use it? Let's say I will create a variable name, let's say v1 is equal to 5. I will write like this. Or I can also write v1 left arrow 5. Or I can also write v1, sorry, I can write 5 then right arrow v1. That means in case of this right arrow, you have to first write the value, then the variable name. Okay. in all these cases, what will happen in the memory location, there will be a place reserved under the name V1 and 5 will be stored there. Okay. So now you must be wondering why the three types of syntax are there. One will do, that means if you'll have only this type of using or this type of declaration or this type of assignment, then it is sufficient enough. So why these three types of syntax? So let me answer you that many of the programmers who are switching from other languages to our language, they have different syntax for um, creating a variable. So for their benefit, for their familiarity, you can use this three types of syntax. So whoever is familiar with this equal to symbol, like the programmers who are coming from the background of C, C++, Java, they can use this syntax. This the person who are having some Perl script or shell script, they may be using this kind of syntax or this kind of syntax. So they may be familiar with this kind of syntax. But are initially they have developed this kind of syntax and it's widely used. That means if you'll ask a R programmer to create a variable, they will use this syntax. And in many cases, this syntax is very much fruitful in declaring variables, objects, and so on. Okay, so it is better. I will suggest you to go through this particular creation of variable. Okay, next. I have written V1 as the variable name. Now, there are certain rules that how to create a variable name. That means how we'll give a variable name. The variable can have a short name like X, Y, V1, V2 like this, or a more descriptive name like age, car name, total underscore volume, and etc. etc. So, what are the rules for creating the variables in R? The variable must start with a letter or a period. That means if you are creating a variable, you must write it either alphabet first, then you can write anything else after that. Okay. So what thing you can include? You can include alphabets. You can include digits. What can be contained here? You can create. You can have alphabets. Alphabets means you can have capital A to Z or small a to Z. Whatever. Anything will do. You can have digits in a variable name. That means 0 to 9. Or you can have a period, dot symbol, that is period. Or you can have underscore. Underscore. So if I'll write A underscore B, that is also a valid variable name. Okay. But if I'll write a underscore AB, then it is not a valid variable name. Why? Because a variable name must start with a letter or a period. That means at the starting point, it should contain an alphabet, a letter, or a period. That means if I would have written like this dot AB, then it is also right. If I write like this uh, dot then 1 AB, then it is wrong. Because after the period, you must have a letter. You cannot have a number after that. So period, if you are starting with a period means you have to proceed it with it should be followed by an alphabet. So these are the rules. So variable name must start with a letter or a period and can be a combination of letters, digits, periods and underscores. If it starts with a period, it cannot be followed by a digit. A variable name cannot start with a number or underscore. Variable names are case sensitive. That means you can create 3 different variables. Age, age. All are having different types of cases. It is in lowercase, it is in proper case, it is in uppercase. So they are 3 variables. They are very much case sensitive. So this variable is different from this one. This variable is different from this one. Okay. And reserved words are built-in words cannot be used as variable. Like whatever values, whatever constant values I have told, or whatever other built-in variables, built-in words they are there in our library, they cannot be used as a variable name. So you must be knowing that what are these reserved keywords so that I cannot use it in variable naming. So let us know all the reserved keywords. See, these are 18 reserved keywords of R which I cannot use as variable name. If, else, repeat, while, function, for, next, break, etc. etc. So these are the reserved keywords and cannot be used as variable name. Okay. So we have discussed so far regarding the constant, types of constant, variable, and how to name the variable, how to create it and assign the values to it, what are the syntax, and next we will go for the data types. Now what are data types? Data type signifies the type of data stored in any variable. That means what is the type of data or constant the program deals with. That is your data type. In programming, we deal with a lot of constants, and these constants can be of different types, and so the data types are of different varieties. So what is the basic classification of data types? Data types can be primitive data types, derived data types, or abstract data types. Primitive data types are fundamental data types. That means whatever type of constants we deal with, directly the type of constant is known as the primitive data type. That means whatever the type of constants we have read, like double, integer, complex, numeric, logical, character, they are all primitive data types. And derived data types means the derived data types are derived from different types of data contained in a grouped data structure. If I know, if we will be knowing the type of data structures, that means a group of constants. I can derive the data type from that set of constants if they are of same data type. So in derived data type, you will find arrays, vectors, matrices. They are derived data types. And in some data structure, you cannot define the data type properly. That means the data type is hidden. The data type is not clearly known. That means in that data structure, you will find the data of different types. So in that case, in that data structure, in that object, you will find abstract data type. Okay. In R, the variable and other data structures, they get their data type at the time of assignment, at the time of creation. That means whenever I assign a value to a variable, whenever I assign a vector or set of characters to a particular data structure, then only the data structure or the variable gets its type, gets its data type. So it is not predefined. The data type of a variable doesn't need it to be declared first. So that's why R is called as a loosely typed language. In context with data types, there are two types of language. One is strongly typed language, another is loosely typed language. C, C++, Java, they take the pain to declare the type of data, to be stored in a variable. That means if you are going to have an integer in a variable, then they declare it as int, then space, then the variable name. So that in that variable, you can store only the integer value. Like suppose I am mentioning here in C and in R. In case of C, if you want to store an integer in a variable, then you have to declare with the int keyword int a. Then you have to write a is equal to 5. So a can have 5 now. In case of R, you directly write a is equal to 5 so that a can have 5 directly. So now here a is an integer. In R, here a is an integer. You don't need to declare int a. So in this case, in C, a can be assigned an integer only. That means after that, if I'll write a is equal to ABC, then it will be a wrong statement. But in case of R, if I'll write a is equal to ABC, at that very moment, a becomes the character type data. So here in the first line, it was integer. And after the second line, a becomes character type. So they don't have the strong typing here. But in case of C, if it is declared as int, that means a can only have integer, nothing else. So they are strongly typed language. In R, it is loosely typed language. So I have a separate video for demonstrating the strongly typed language and loosely typed language properly. So I suggest you to go through that particular video so that you can better understand. Okay. So now if you have any queries, then feel free to comment and write down your doubts properly so that it can be answered. And if not, then you can proceed to the next video. I suggest you to go through the video once again if you are stuck at some place so that you can have a better understanding. And so for this topic, it is up to this mark. And after that, I will go for the next programming fundamental topics. And till then, have a great day and great learning. Thank you all.